Hey guys, welcome back to my channel. In the previous video, we did till sub-question number 7 of question number 6 of exercise 13A, OP Malhotra's textbook for ISC Mathematics. Today we'll be completing the sub-questions of question number 6 and we'll start off with question number 7. So let's begin. So sub-question number 8 of question number 6 is the integral of sin x into root of 1 minus cos 2x. Now we know that we can remove the root sign by writing 1 minus cos 2x as 2 sin square x. Now we know that we'll get root 2 and this sin square x becomes sin x. Sin x into sin x is again sin square x. We can take this root 2 outside and we can write sin square x again as 1 minus cos 2x by 2. We can take this 2 outside, root 2 and 2 will get cancelled and we'll be left with 1 by root 2, integral of 1 minus cos 2x. 1 becomes x, cos 2x becomes sin 2x upon the coefficient of x which is 2 plus c. And we can write sin 2x as 2 sin x cos x. The 2 and 2 will get cancelled and the simplified answer will be 1 by root 2 into x minus sin x cos x plus c. So very similar to the previous answer. And this is the final answer. Question number 9 is the integral of cos x minus sin x upon cos x plus sin x into 2 plus 2 sin 2x. It looks very complicated, but it's actually quite simple. All we have to do is, I'll write this again, and we can take out 2 common. This will become 1 plus sin 2x. Now we can write the 1 as sin square x plus cos square x, and the sin 2x becomes 2 sin x cos x like we did previously. And now this same thing again I'm writing. I can take the 2 outside. This 2 can go outside as a constant. And this is a square plus b square plus 2ab. So this becomes a plus b the whole square, which is sin x plus cos x the whole square. And we can see that this is the denominator. So one of them gets cut when we are left with sin x plus cos x. So this is a minus b, a plus b, which is a square minus b square, which is cos square x minus sin square x. And we know that this is the formula for cos 2x. So we get sin 2x by 2 plus c. 2 and 2 gets cut and the final answer is sin 2x plus c. Okay guys, moving on to the 10th sub question. Again, this looks quite difficult, but it's actually very simple. In integration, you just have to divide the question into simpler terms. Normally, sometimes you would think that we should make the denominator common. But here, instead of making the denominator more complicated, let's make the terms simpler. So we can take these as 3 separate terms. One of them would become 4 by cos square x. The next becomes minus 5 sin x by cos square x. And the third term becomes 1 upon sin square x cos square x. So this thing that looks so complicated, we can easily integrate these 3 terms separately. We can take 4 outside and integrate 1 by cos square x separately. We can take minus 5 outside and integrate sin x by cos square x separately. And and we can have 1 upon, so we can do this like we did earlier, sin x cos x the whole square. Okay, so now we can write 1 by cos square x becomes sec square x minus 5, and we know that this is sin x upon cos x into cos x. Sin x by cos x becomes tan x. 1 by cos x becomes sec x. And this is sin 2x by 2, the whole square. Sec square x, the integral of that is tan x. So this is 4 tan x. The integral of sec x tan x is sec x. So this is minus 5 sec x. Now this will become, so this is sin square 2x by 4, which is 4 by sin square 2x. The same thing here. Plus sin square in the denominator becomes cosec square in the numerator. So 4 cosec square 2x. You can take the 4 outside, it's the same thing. And the integral for cosec square is minus cot. So this will become minus 4 cot 2x by 2, which is the coefficient of this. And the 2 and 4 will get cancelled. So the final answer will become 4 tan x minus 5 sec x minus 2 cot 2x plus c. And you may wonder that the answer given in the textbook is different for some of the questions that we've solved. But because it's indefinite integral, there are many methods to solve one question. So different answers are correct as long as your process is correct. So this answer is also correct and the textbook answer is also correct. 7th sub-question of question number 6. It looks very complicated, but we are going to do exactly what we did in the 6th sub-question of question number 6. So we'll be writing the numerator as it is, and we can simplify the denominator. We ultimately have to remove the root sign. So this means that we have to bring this as a whole square. So we can write 1 as sin square x plus cos square x. And we can expand sin 2x and write it as 2 sin x cos x. So we can see that this becomes a whole square. This becomes a plus b the whole square, because this is a square plus b square plus 2ab, which is the expansion of a plus b the whole square. So sin x plus cos x the whole square gives you sin square x plus cos square x plus 2 sin x cos x, which is ultimately 1 plus sin 2x. So the square root sign will get removed and we will be left with sin x plus cos x in the numerator as well as the denominator, which will ultimately turn into 1, and the integral of 1 is x. So the final answer is nothing but x plus c. Or if I'm not clear enough, I'll definitely work on that. Okay, moving on to the 7th question. It's quite similar to what we've done till now. It's root of 1 plus sin x by 2. So here in the previous question, we had 1 plus sin 2x, which is why we had sin x, sin square x, cos square x in the expansion. Now here we have 1 plus sin x by 2. 1 is sin square x by 4 plus cos square x by 4 plus 2 sin x by 4 cos x by 4. And I'm writing it like this because x by 4, now x by 4 is the half angle of x by 2. So I'm using the double angle formula here and expanding it as 2 sin x by 4 cos x by 4. Like how sin 2x is 2 sin x cos x, sin x by 2 is 2 sin x by 4 cos x by 4. And because I want to remove this root sign, I'm not writing 1 as sin square x plus cos square x, because that won't give me a square plus b square plus 2ab. Though that would also be correct, but it won't help me in any way. That's why I'm writing this as x by 4, sin square x by 4, cos square x by 4. So that I'm left with a square plus b square plus 2ab. Which is why I can write this as sin x by 4 plus cos x by 4 the whole square. Now the root sign will get removed, so I'll be left with sin x by 4 plus cos x by 4 dx. The integral of sine x is minus cos x, so minus cos x by 4. The coefficient of x is 1 by 4, so I write that in the denominator. Integral of cos x is sine x, so plus sine x by 4 upon 1 by 4 plus c. Now taking this in the numerator, I'm left with minus 4 cos x by 4 plus 4 sine x by 4 plus c. And that is the final answer. So that's it for today, guys. Thank you so much for watching. In the next video, we'll continue with question number 8, 9, 10, 11 and 12. So see you in the next video, guys. Thank you so much for watching. Bye.